very relevant. So, one of the leaders of bioethics, I'm going to tell you today about, sort of give you a general overview of ethics and genetics. And one of the, what's often considered the Bible of bioethics in the US, Principles of Bioethics by Beecham Childress. Tom Beecham died last week. He was also married to Ruth Faden, who is another major figure in the field and founded the Berman Institute of Bioethics, and was the person who hired me into my job and has been a mentor. So, sorry. But going from Tom's funeral into his classroom is just odd. All right. So I'm going to talk to, this is sort of a broad overview of some of the ethical issues I'll go into, and then I'll also talk about policy at the end, although I started late, so we'll see how far we get. So the ethics in genetics and genomics is a field that was really, I mean, obviously it is part of bioethics, but it was catalyzed by the ELSI program, the Ethical, Legal, and Social Implications program of the Human Genome Project. So very early in the Human Genome Project, after the funds were appropriated, which I think was 87 or so, and before, like right at the beginning of its launch, there was a press conference with Jim Watson, who was the first head of the Human Genome Project of Watson and Crick and Franklin. Among other things, Jim Watson's a bit of a live wire, and he was holding a press conference, and at some point a reporter raised their hand and said, so if you're going to sequence like the whole human genome, that's probably going to raise some ethical issues, right? And Jim Watson took a beat and said, yes, and I'm going to devote 5% of our budget to studying those issues, and created the largest federal funding project for bioethics. And basically created the field of ELSI. These are the original goals of the ELSI program. I think if you review them, you'll see that they all feel really relevant still. I think it's important to note that it's not because we haven't solved any issues or gotten better at this work, but the technology keeps changing, right? And as I'll come to later, the kinds of issues, the kinds of ethical issues that arise when we've never sequenced a human genome are different than when a human genome costs $100 million, which are different than when a human genome costs $1,000. So the technology keeps moving, and we have to adapt as it does. One of the major issues we think about when we think about genetics and ethics is a concern about privacy. Right? There are lots of different definitions of privacy. The one I like to use is from Madison Powers. A condition or state in which cognitive access to personal information is restricted. I get to decide what you know about me, right? And why do we care about genetic privacy in particular? Well, this kind of information can be used for good or bad purposes, right? To help us in terms of directing us toward the right kind of medical treatment, or for bad purposes, to restrict the kinds of opportunities we have access to. It can affect our social and economic well-being, right? Again, if certain benefits are restricted or given. It can affect our psychological interests, right? One of the sort of principles from the very early days of the Athg program is the right not to know. Not everybody wants to open the Pandora's box of the human genome, and people should have a right not to know. In fact, the canonical case here is Huntington's disease, right? It's like worst case genetic disease. 100% penetrant above 40 repeats, usually don't develop symptoms until after you've had your family, and there's nothing we can do to help you. 100% fatal. So in surveys prior to, it was also the first human disease gene we matched, right? And in surveys of people who are at risk, so had a parent or a grandparent who had developed the disease. In surveys of those folks prior to the mapping of the gene, when asked if you could get a test that would tell you pre-symptomatically whether you were going to get this disease, 70% of folks who are at risk said, yeah, I would want that test. The test has been available since the mid-80s. Less than 20% of folks who are at risk get the test. People don't want to know. I'm sure that would change dramatically if a treatment or cure became available, of course, but in the absence of anything to do with that information, most people don't want to know anything medical to do with that information. People have concerns about, so I did a big study on this, and folks have concerns, for example, about symptomatizing, like the second they drop something, or forget a name, or misplace their keys, they start worrying that that's the beginning of it, right? Also concerns about relational interests, right? If other people know, they might be watching you for dropping your keys, forgetting a word, etc. Another example I like to give is, I have two kids. They're both in high school now, but when they were in elementary and middle school, I'd go and talk to their classes about genetics and ethics and stuff. I have this inflatable 5-foot double helix that's in my office. It's in my office because it was a blunt weapon at home, so I can probably, no. I probably shouldn't take it back home. But I was talking to my younger kids' 3rd grade class, so this is 8-year-olds in Baltimore City, about genetics and ethics. And I was like, okay, so if I could look in your DNA and tell you that when you grow up, you're going to get a terrible, awful, no good, very bad disease, would you want me to tell your parents? This entire class of 8-year-olds in unison yelled, no! Well, that is fascinating. Why not? Well, your parents might not let you do what you want to do. Your friends might treat you differently. Like, these 8-year-olds got it. There is something special about this kind of information and the power that it has. And autonomy interests, like your parents might not let you do what you want to do. But of course, when you get older, right, someone else might not let you do what you want to do. And who might those people be? The government, employers, insurers, mortgage lenders, advertisers, right? It used to be the case, not so much anymore, that I would get tons of ads from 23andMe. Like, they knew that I was interested in genetics, and they targeted ads towards me constantly. Like, what kinds of ads might I get if they knew not just about an interest in genetics, but in fact, the constitution of my genome? And again, and family and friends, and I've already talked about that. And privacy concerns are most often paired with concerns about discrimination, right? Can this information be used by others to make decisions about you. And again, what liberties you have and don't have. Will you be stigmatized? Because, for example, in the Huntington's disease case, will people treat you differently like you already have a condition, a neurodegenerative condition, when you don't? An allocation of restrictions and liberties. The tricky bit is that there's no way to guarantee that this information will stay private anymore, right? Again, as I said at the beginning, the kinds of privacy concerns you might have when a genome costs $100 million are different than when it's $1,000. And there are things like 23andMe and Ancestry.com, right? And it has historically been the case, it's still the case, that a lot of genetic research doesn't actually count as human subjects research, because most genetic research is like you need a cheek swab or a blood draw, or you're getting leftover pathology sample. So there's no physical risk to the individual, right? The risks are primarily informational. And we thought that if you stripped all the identifying information off, or if you pooled samples, or if you put a code on there, that we could eliminate the informational risks. And if you can eliminate the informational risks, you've eliminated the need for informed consent. So it doesn't count as human subjects research if you're able to eliminate reasonably the risks associated with the research. But in 2008, this paper from Homer et al. Came out demonstrating that actually if you had a pooled sample and you had an identified sample, you could algorithmically figure out if that identified sample was present in the pooled sample, re-identifying that sample. And that, I think, probably sounds pretty straightforward now, but at the time, like, I remember where I was when I heard this paper came out. It was a big deal. And in the years that followed, additional papers came out demonstrating that the protections that we thought we had that justified the non-human subjects research designation weren't so strong anymore. And if that Homer et al. Paper was sort of the first shoe to drop, the Jimrick et al. Paper was the second. I always like to point out that Melissa Jimrick was a grad student at the time she did this work in Jan Ehrlich's lab. And she demonstrated that you could go from de-identified genetic data to names, addresses, family trees in the course of an afternoon with publicly available information. And she was able to do that because 23andMe and Ancestry.com exist then, right? She looked at STRs on the Y chromosome, very easily identified folks. And in a paper now a number of years ago, I think 2017 or 18, Jan Ehrlich demonstrated that it would take about 4% of the US population to participate in those data, in 23andMe, Ancestry, et cetera, for 90% of the US population of European descent to be identified through those databases, right? And we passed 4% a long time ago, although 23andMe is now like very close to going out of business. But their data will be sold to somebody else. So, and this is an important tie to the science, right? It's people of European descent who are at most risk because we have the largest blocks of linkage disequilibrium, the least genetic diversity, and so are most mindful. We're also most populous in those databases. And then here at Hopkins, privacy, another privacy concern is particularly relevant, which is that related to Henrietta Lacks and her family. So if you haven't read this book, please do. It is a very compelling read. It'll take you a weekend. And it's been very important here at Hopkins for a variety of reasons. and has shaped decisions we've made about governance of genetic data and stem cell lines. So here at Hopkins, we actually have a more stringent policy about sequencing of unconsented samples and the creation of immortalized cell lines than the federal floor because of our experience with Mrs. Lax and her family. From a privacy perspective, I mean, so the HeLa genome was published online in 2013 from a group in Germany who in their press release said, but don't worry, you can't tell anything about her family members from her cell line because it's been propagated for so long and all of that, which is false. Everybody yelled and screamed. They pulled it offline. Then a group in the U.S. that had also had a similar paper in press, but wasn't out yet, went to the NIH and was like, we were about to do that too. And the NIH created a data access committee specifically for the HeLa cell line genome to make decisions about how it can be used and published publicly and how it can't. And members of the Lax family sit on that community advisory committee, as does Ruth Hayden, who I mentioned earlier. The other things, is that in addition to the impact on governance of science here at Hopkins, there was a groundbreaking, but there were shovels, but no ground was broken. I don't quite understand why they do that, but my office is in the Berman Institute. It's across from the 1812 building. It's the little brick building. It's the original East Baltimore Police Department. Yes, we still have cells. That's where our postdocs and grad students sit. Poetic. And next to us is a garden. That's going to become Henrietta Lacks Hall. It's supposed to be, it's supposed to already be built, but pandemic and all the things. And now they're hoping we can move in at the end of 2026. But there will be now, and the first floor of that building is planned to be very sort of open and welcoming to the public. And it's really, in terms of a university putting its money where its mouth is, I think is an important step for us to take with regard to the Lax family and that the legacy. All right. First question. Does privacy exist? Do you have privacy concerns? This changes every year. I think people, you're nodding energetically to the, does privacy exist, or do you care about which side?
I think it exists to an extent. You have privacy of your mind, but not of your actual data. So there's that. But I feel like everyone should always have privacy concerns because there's always a camera pointed at you. There's always something that can track you down. There's electronic records of you everywhere from the day you're born. There's record of you everywhere.
Yeah. So does that, what does that lead you to in terms of action? Are you just cat's out of the bag, horses out of the barn? Or?
I feel yes, because it's there was some things out of my control that I had no say in that are out there now that I can never take back.
Right.
So might as well just live freely now. I'm not going to go around posting my social security number or anything, but yeah.
It seems others are going to take care of that for you. So do you have concerns about, like, from a genetic privacy perspective, do you think, like, do you have concerns about genetic privacy, or are you, are you sort of, there's no point?
I mean, I guess also to an extent, because I'm one of those over 4% of people have actually put their data into 23andMe.
Mm-hmm.
So it's like out there, or whatever they have on file is like out there. So there is some concern. But obviously there's nothing I can do about it now because I did it as a dumb 18-year-old. So nothing I can do about it.
I think I kind of fall in the same bucket where I don't have a lot of faith in our systems to prevent most of our information from becoming private.
Mm-hmm.
But I think that there is still lots of like worthy work to be done in terms of discrimination, of saying like it may be possible that because governments try to keep things secure and people don't try to access them, corporations tell us that they're always on our side. People will learn information about you, but having legal frameworks, at least as a country, that we say even if someone were to learn this information about you, it can't be used against you. For me, that's much more important. Mostly just because I just don't have faith in our internet-connected system that things are going to be secure forever from all people.
So clean it up on the back end. Like make sure we have good governance or policies to protect.
I agree with Carter, and I also think that companies like 23andMe, or like as the individual genomic testing becomes more available to the public, I think that this privacy conversation needs to be very brutally honest with people and have people understand, like, yes, there is a way technically that they could, they have your data and it's not entirely 100% seal-proof private, but neither is almost like any way we put our personal information out there. And so I think with Carter, I'm in a similar boat where I'm willing to accept that risk as long as I know that that can't be used against me, hypothetically. But other people might not be willing to take that risk, which is fine, but I think that they need to be counseled on that, hypothetically, before they get their testing results and stuff. So, yeah.
Do you know what entities are capable of buying like data from 23andMe, for example? What do you know who would be able to purchase that? Can anyone just purchase? That's like the kind of concern that I have. Like, who is allowed to purchase this kind of data?
Well, they had a big contract with, I think, Pfizer to do drug development. Academics can buy access to their data. My biggest concern there is when 23andMe goes under, who gets their data. Because there's no guarantee that they will honor any protections that 23andMe had for folks who participated in their service.
I think I worry because I don't know who is not allowed to buy the data. And so the reason why that could be a concern for me is kind of learning about sociogenomics being like a newer area of science. And I understand that it's for a lot of people who are in that field, it exists to maybe create social interventions to improve social inequity. But my concern comes in when you have folks who are buying the data to maybe justify some like eugenic theory that without fully understanding like the nature of how variants contribute to like human behavior, so they can say, well, this group of individuals is this way because of their genetics, and like that can maybe be used. Like, I feel like once you publish research, like that cat is out the bag, and people do with it like what they will, good or bad. So I don't know. That's like what's concerning me.
Yeah, because different people are going to have different interests in the data.
Is there a possibility that insurance companies can buy into 23andMe?
So health insurance, no, currently cannot do that. Because of the Genetic Information Non-Discrimination Act, health insurance and employment contexts, there are protections. There are not protections for other forms of insurance. So for long-term care, disability, etc. She was.
No, you got
No, this is actually related to what I was about to say. I think also the context of the country matters because of like all the things that you just mentioned. Like the United States, like currently, like insurance has to accept pre-existing conditions, and like as far as we know, that's sticking around. But like if that is not something that's sticking around, and they can access like genomic data, or like when people are trying to apply for life insurance, then there's genomic data that's like used against them. Or like we don't have these really robust systems for like post-retirement, like expenses and that kind of thing. I think it's like even more of like a, I don't know, like ironic or like paradox in the United States that like we've created these companies and like we really like fuel them with like information. But we're also probably one of the most like susceptible countries where that can then like have a really large outcome on your like quality of life like down the road.
Yeah, this is an interesting time to be giving lectures on ethics. Because historically, concerns about privacy, lots of people are like, I haven't done anything wrong. No one's gonna come after me. I'm fine. But things are shifting, right? Yeah.
Just as like a little anecdote, I had a sibling who was, doing some carrier screening because they were considering to start a family. And their provider actually recommended to them. They said, just make sure, like, if you are planning to apply for life insurance or a couple of these other things, I would recommend that you do it before you get any of these results. Because she's like, we have people in our clinic who will get worse offers because the life insurance will say, hey, we need to see your medical record, we want to see who you are, and they'll say, oh, you're a carrier for this or this, or you have a higher propensity for that. So like, we're gonna, which was kind of wild to me, like seeing it out in the wild. I'm so used to like, I don't want to say like high-minded, but we have these ethical things and we're like, oh, someday it's going to impact somebody, but this is like in the clinic today.
Yeah, no, if you see a genetic counselor to talk about genetic testing, they will tell you insurance up before you get testing because all of those other insurances can access your data and can use it in making decisions about access and premiums and all of that.
Have people ever tried to like challenge that and say they shouldn't and it just didn't like get anywhere or gain any traction or?
I don't know in those other cases. I do know it took 13 years to get GINA passed, which is again just protections in the employment and health insurance context.
Yeah.
And it was largely because folks weren't using the data, so there weren't cases of discrimination, and so Congress, I don't know if you've noticed, is a very reactive body. It's not a very proactive body. And so in the absence of people yelling and screaming about genetic discrimination, other than the geneticists, it just was hard to get them to do anything.
Right.
And for many, many years, those other insurances weren't using it yet, in part because they were worried about the backlash they'd face. And in part because there just wasn't enough that we knew.
Yeah, that's what I worry about though. The more we know and the more that people are going to, like the general public are going to be able to comprehend things, and then insurance companies are going to be able to implement those new genetic pieces of knowledge. There's no proactive protections there, it seems.
Yeah.
Yeah.
And we had, I did this study I mentioned of Huntington's disease. First disease gene we mapped, first thing we could test for pre-symptomatically. But because it's so bad, like folks were worried that if people pre-symptomatically found out that they were going to develop Huntington's disease, that they would kill themselves. So they only made testing initially available in the context of 2 clinical trials, a large one here at Hopkins and a smaller one at Mass General in Boston. And me and my team went back and found as many folks who went through that in the 80s and 90s to find out how they did long-term having pre-symptomatic genetic information. And we had one person who, they were like, I would love to participate in your study, but I never told my insurances that I went through this study in the first place. I never told them that I know this information, and I'm afraid that participating in your interview study today, somehow the information will get back to them. So it's a very real fear.
Yeah.
Are there any protections preventing insurance companies from buying hacked data? Because 23andMe has been hacked
Yeah.
notoriously several times. And
I have absolutely no idea about that.
So, our
Kate
insurance-
Spector-Baghdadi, who is a lawyer and a bioethicist at the University of Michigan, might know, but I don't know.
So it seems like insurance companies are the monetary drivers for hackers then.
Potentially. I mean, that's proven to be the case in car insurance, right? The car insurance companies are buying all kinds of swept up data from cars.
Yeah.
So, yeah, I don't know. Any other comments, questions about what I've talked about so far before we move on? Yeah.
Is forensics part of this conversation? Like people who, like, you know, the police gives them coffee.
Yep. I will come back to that.
Okay.
All right, now I'm going to run through a series of ethical issues, dilemmas that come up in the context of genetics. In the context of Mendelian conditions, there has long been a conversation about what constitutes normal human genetic variation versus disability, right? And who gets to decide when you've crossed over from normal human variation into disability. And the canonical cases here are achondroplasia and deafness. These are two communities that both have genetic conditions that are causing their phenotype, but that communities and cultures have grown up around them, right? So little people of America, people with achondroplasia, they are folks of short stature, and if they have means, they have been able to create built environments around them that match their stature. And in appropriate built environments, they are not disabled. And so they view the environment as being disabling and not themselves as disabled. And in fact, many folks with achondroplasia would prefer to have kids with achondroplasia, because not only does it mean that those kids will be able to be part of their communities and cultures in a more thoroughgoing way than they would be able to if they were of normal stature, but also it's just hard to manage a very, very tall teenage boy when you're a person of short stature. And then the built environment becomes difficult for the normal stature person, etc. So they don't consider themselves disabled. The same is true of the big D deaf community. People with deafness who consider deafness a culture, and as I stated before, consider the environment as disabling, not as themselves being disabled. Right? We have Gallaudet in DC, which is a university for folks who, with deafness or who are hard of hearing. I mean, they have their own language. If they can create built environments that give them visual signals as opposed to auditory signals, for example, when the phone rings or the doorbell rings. There's Braille, wrong. But, yeah, sign language. So again, who are we to tell them that they're disabled when they have these rich, meaningful lives, communities, norms, cultures? There's also concerns about the impact of testing on existing communities, right? Folks who have access to prenatal genetic testing and can test a fetus and then make a decision to abort the fetus if that's what depending on where they live now. If abortion is something they have access to, and pre-implantation genetic diagnosis that allows folks to decide which embryos to implant and which not to. Right? The extreme case of this is in Iceland, where they have a very good national healthcare system. Everybody has access to good prenatal care. And there is a norm of prenatal testing and abortion in the case of trisomy 21. So annually, 2 or 3 kids are born in the entire country who have trisomy 21. Here in this country, folks with Down syndrome are often mainstreamed into classrooms and have lots of supports, etc., around them. But think about what that would look like in a country where you're one of a few, right? And how that impacts the services available, the drive to do research, the kind of life you have, the reaction of others to you if you're the only. It changes the kind of life that person might have. So concerns about how that kind of testing can impact the folks who are there, and the families who are there who have the condition. In the context of complex traits, there's of course the probabilistic nature of the tests, right? It's not a clear answer. And it's concerns about, it's not just genes, but genes plus environment that lead to the phenotype, which raises all sorts of just uncertainty in those cases. There's also a difference between early and late onset conditions. You know, I was talking about Huntington's disease before, a slightly less extreme case with, and more probabilistic case with breast cancer. Like, how do you think about being a healthy person with a pathogenic genetic variant, right? What does that do to one's sense of self? How does that person think about or perceive themselves, and how do others perceive them? Should we be doing pre-symptomatic genetic testing of kids? Historically, the norm has been that we don't do genetic testing on kids unless you're going to change medical management in the pediatric period. So for certain colon cancer syndromes, right, where you would start screening early. But because it has become so much less expensive to do a whole exome or a whole genome, as opposed to a whole bunch of single gene tests or panels to try to find out what's going on with the kid, we now routinely have full genomic data on infants. So how do we think about that? And in fact, one of the people who I interviewed as part of my Huntington study called us later and said, "Can I get my 3-year-old tested?" All those 8-year-olds in Baltimore City didn't want their parents to know what their genetic data was. So how do we think about when we do that sequencing, where do those data live? How do we treat them? Who gets access to them?
Who has the right to ask?
Yeah.
I'm curious, how much of, maybe this is a subset of the population, but of people who have the means to sort of selectively reproduce, who could use IVF or something like that, how often are they saying, well, I have Huntington's disease, or I know I'm a carrier, or I know I have Huntington's disease and I'm going to die when I'm 50. I have significant disposable income, so I can afford to, only implant the embryos that won't have this disease. How often do you see that happening out in the field?
I mean, I don't have perfect data on it, but absolutely people do that. I mean, and in fact, even during when the study was running here at Hopkins, in the 80s, mid-80s to mid-90s, they had people come to Hopkins and say, look, I don't want to know if I am going to get it, but I want to avoid my kids getting it. So I want to do IVF, and I only want you to implant unaffected embryos, and don't tell me if you had to choose based on genetics. So that was happening even then. It absolutely happens now. The other thing I can tell you is that among the people that I talked to, lots of them just had kids the natural way anyway, knowing, in part on the argument that if I wasn't willing to have a kid with this condition, it's like saying my life isn't worth it. It's like a denial of their own value as a human.
And so they went ahead and had kids anyway, and some of those kids had expansion. Some people choose to adopt, some people go through IVF, but there's not a uniform response to that condition, for sure.
It's really complex.
Very complex.
How do you determine what's really interesting about bioethics to me is what ultimately determines whether something is right or wrong? Because if there's different viewpoints on the issue, how does anyone come to a conclusion of what's? I think sometimes it's a little more obvious, this is absolutely not okay, but when it's like this, how does one determine what's okay and what's not okay?
Yeah. So the Berman Institute's tagline used to be "No easy answers." Right, because questions don't really come to us unless you have two fundamental values in tension. Right? Genetic information is really powerful and can do a huge amount of good, and it can be used in these bad ways. So how do you make decisions about, even in the, I told you that genetic research often doesn't require informed consent, right? How do you think about the value of genetic research against the autonomy interests of people, of individual people? That's not an easy conversation, right? So a lot of what folks in bioethics do is teasing out all of these issues so that at least they're all on the table and they can be weighed against each other, and you can determine, okay, that's actually not a concern because from a technical perspective, that's not going to happen, or that disease is of significant, high enough level of risk or seriousness that it's okay to override this interest over here. But if it's not, if it's like height or eye color or something, then no, that risk is not worth it. Right? So it's often about weighing and balancing, not about 100% right, 100% wrong.
I see.
Any other questions? That was a great question because it forced me to say that to you guys.
So is the line in the sand of government policy between autonomy and self-selecting eugenics?
I mean, it's more complicated than that. And I'll say, but what I will say is, I'll get to you just a second. In the US, autonomy is the first among equals in terms of the ethical principle. And this is not uniquely Western, but is a key trait of Western bioethics, is that autonomy is really sort of the prime ethical principle. In other countries, it's solidarity, right? Or community. It really does, right? Oftentimes, it'll be described as in the US, we care about the fingers, in other countries, they care about the hand, right? There's a African value called Ubuntu, which is I am because we are. We don't have anything like that in the US. So it does, the country that you're in, the culture that you're in, absolutely shapes. And I should say Western, but Western and European, right? My indigenous colleagues in the US absolutely have more communal-oriented values than the mainstream population in the US. Yeah. Okay. There's also long been a conversation about genetic exceptionalism, and this continues today. There are some people who say genetic information is like any other health information, we should stop treating it differently. And other people who say, no, it's special because of these reasons here, right? It's not just your data. It's relevant to all your genetic family members. It's intrinsic. There's nothing you can do about it. Gene editing aside, it's predictive, and it's usually probabilistic, right? but it shapes what our policy responses are to it, right? For a long time, people had shadow records. Even today, genetic information in Athg is like a scanned PDF, which makes it really hard to use, access, etc. So, but this is an issue that hasn't changed that much, except that there are now, I think it's broken out a little bit, like pharmacogenomic variants, for example, are much more like regular regular medical information, as opposed to a BRCA mutation or something else that is highly probabilistic, potentially very serious, but you might get it, you might not. So because we've learned more, we're able to sort of subdivide the kind of genetic information we do know about, so that some of it, yes, regular medical information, some of it not so much. But if it isn't special, why shouldn't your insurance companies have access to it, or your employer? Right? Our policy suggests that there's something special there, because we do have GINA, Genetic Information Non-Discrimination Act. It isn't just like other medical information. Like, what if the condition is directly relevant to your job? Sudden cardiac death and you're a pilot. Or on the behavioral end, alcoholism and you're a bus driver. Why shouldn't those employers be able to make you take a genetic test?
Because they would be equating probabilistic with deterministic.
I still don't understand the nature of, like, they say a variant is associated with alcoholism. We still don't understand much about what we have in these like huge genome studies. We see a bunch of variants. We do a lot of cool statistics, but we still don't really know what
Yeah, which relates to the probabilistic versus deterministic, right? Are you looking at an actual genetic test, or are you looking at a PRS, right?
I think even if we did know perfectly, even if we could say with like a very high degree of certainty at this age, by this point, you're going to be an alcoholic or something. I think, I hope not, but I think that in America, I think it goes back to autonomy. And a lot of times we just trust the individual to make that sort of decision rather than society making the decision. And that's probably different in other countries. I'm sure that's different in other countries. But we say, you know that, and if you were a moral person, you would do something about that information.
Mm-hmm.
But we are going to let you decide as an individual. And maybe it means that more of us die in bus crashes and plane crashes, but so far.
So I feel like to her point though, in asking that question, it's like, is someone's autonomy worth like others' livelihood?
I think in America it is. I'm not saying it should be. I'm not saying it should be, but I think that's how we
That's
are.
just like how it is.
Yeah.
I agree with you, Carter. I think if it's something that's like very specifically known, this person is going to suffer from this at this age and be employed like this. But at the same time, I do think that it's somebody's own personal business to decide what they want to do with that. But I do think that if they receive that information of, oh, I'm going to have X, Y, Z, again, I feel like maybe if they have a genetic counselor, that person could explain to them the implications on their work life, because that might not be something that immediately comes to mind for people. And then, yeah, I guess trusting them to make the
What about
right
like,
decision.
in terms of the employer though, what about, I mean, for the individual with their autonomy, like, there's not really, I mean, there's a risk to them, like, obviously, like, if you have like an alcoholic bus driver and like, God forbid there's an accident, there's like an obvious risk to them, but the employer like has a risk too, which is that
Right. Yeah.
that could be millions or billions that they lose knowing that someone, like, I don't think this is possible now anyways, this is like probably not even a realistic scenario, but like knowing that I employed someone who was like very likely to be an alcoholic,
But yeah, I don't know. I think the alcoholic example is hard because it's such like a complex
Yeah.
trait thing. Like we could easily have plenty of
Yeah.
alcoholic bus drivers right now that don't have that genetic variant that predisposes them to alcoholism.
That's true.
So it's sort of like, well, how can you discriminate against this person but then hire someone who doesn't have the variant and ends up being an alcoholic anyway? I don't know. So, but I think it's for like maybe like Huntington's disease, for example. That's a much more
Right.
like stringent thing that is like more directly discriminatory almost. I think kind of.
Is there a difference between being an alcoholic and having a genetic predisposition to alcoholism?
I would say so.
Yes,
Good.
definitely.
And on the AHD thing, I'll say there was one of our interviewees was a nurse, and she didn't tell her employer, but she told her close colleague, like, if you need to tell me if you see me start to slip. And when that person told her that, she retired.
Yeah. Yeah, I think it's a lot more problematic when you get into the realm of employers discriminating against employees for a disability that they know they're going to develop eventually. I think when you open that door, you are opening the door to them discriminating against maybe the more complex trait, the more gray area type of disorders.
I also feel like, how do you hire anyone? Because I feel like majority of
I know.
I feel like everyone.
We all have something.
Yeah, like everyone had, or
Yeah.
I don't know if I can say 100%, but most people have some type of variant that like.
Yeah. No, we all have something, we just don't
Yeah.
understand
Yeah.
all of them yet.
And then you're kind of selecting for people that,
Yeah.
say somebody doesn't want to know that information about themselves, they might be more employable even though they have the same
Yeah.
variants as somebody who did want to know that about themselves, so.
Did you wanna, you had your hand up earlier.
I was just reminded of Minority Report, you know, the movie with Tom Cruise, where like you live in a society where you're able to identify people who commit crimes before they commit crimes, and you just arrest them because you're able to predict with enough certainty that you are going to commit that crime, and now it doesn't even have to happen because we figured it out and we solved it. And I think we will get somewhere. Like I think we will eliminate enough uncertainty that we could say with a very high confidence about someone's future. And maybe, you know, maybe that's wrong, but I think we could do that with a high degree of confidence, and I still think we shouldn't make decisions by that, because that uncertainty is just something that I want, like in human life, is like not being sorted into whatever my destiny is, even if it's pretty confident what I'm gonna end up doing with my life, you know.
I feel like that's also like the human experience though, like uncertainty is like what makes us so successful anyways, like despite all odds against you, like you, I don't know, I feel like there's something about being a human being anyways, like we're more likely to fall into that 1% or 1% more often than not range than like the rest of nature, I guess. Like that's like why I feel like this part of what we exist, just to defy any odds that exist against us anyway, so.
And make lots of mistakes.
Right.
So, can I answer this?
Yeah.
I'm a cynic, and so like,
Bring it.
why do insurance companies and employers want our genetic information? From the insurance perspective, it's to raise rates based on some
To manage
Yeah.
risk.
Yeah.
Yep.
like manage
And
risk.
protect themselves, yep.
Right, and employers, for a similar reason, they don't want people who are maybe at high risk for a certain.
Because in this
Yeah.
country, companies pay for health insurance.
Right, and so having these two entities have this type of information can only be bad for the individual.
I think it.
Or maybe it should be lower, because I don't have any risk.
I've never
So
seen my
he's gonna
insurance
get a
go
higher
down.
rate.
I think that is true because there's this view of self-preservation. With that culture, that's what we get. If we have
You
a
mean
culture
of the companies?
of the
Yeah.
companies, the employers, even ourselves, but if they have this
We wouldn't
view-
still be here if we didn't have a strong drive to preserve ourselves.
Exactly. And so, like, if the employers instead had a community preservation mindset, right? Hopefully, they would use that information to protect the employee, like you have up on the slide, right? Hopefully, insurance companies would say, "Oh, well, we don't need to cover these things that you're not predisposed for, but we're going to help cover these to a greater extent."
Mhm.
That's not the mindset
Mhm.
that's here, even if it's the best mindset for actually making all this work.
that's why they have to put parameters for companies to do the right thing, quote unquote, like the right thing, or else they wouldn't actually do that.
It's just a money game at the end of the day for them.
Would it ever be possible for the government to take on some, I mean, not necessarily, but some element of this risk, like knowing, because I feel like that's why the government also exists, why research is funny, because they can take on risk that but if you know, like,
So you're triggering me.
Yeah, I'm just thinking, like, if you know you have lobbying corporations and their like concern is the risk, like, of operating a business model where like you're hiring people who are at risk for developing a disease, and why not just like take on the difference? I guess I don't know. Or offer them some incentive to do it. I feel like that's kind of the purpose of the policy, though, is to incentivize business to not do the wrong thing too.
Probably because the dividends that pay to do the wrong thing pay more.
I mean, in a country like the UK that has National Health Service, there is motivation. Like, you would want this information because it does help bring down costs for everybody if you know in advance and can manage a disease from the beginning or before the beginning, right? It helps everybody by bringing overall costs down, but that's just not how our system works. Okay, I am absolutely not going to get through all of my slides, which is totally fine. This is a great conversation. There are also concerns about genetic determinism, which has already come up, right? The idea that, like, if this were me, that it would be like my self-portrait, right? That you are your genotype. But that has significant implications for free will, our ability to make our own decisions, to have that autonomy, and for moral and legal responsibility, right? Whether or not someone is morally blameworthy, if they couldn't have done anything else, their genome made them do it, right? And in the legal context, even if someone actually did it, right? Are they culpable for it? Are they legally culpable for it? And what should the sentence be? Right? Because you might think the sentence should be different if someone killed someone because out of malice and spite versus they couldn't help but do it. Right? Jail versus treatment might be somewhere your head goes. So how we think about the importance of genetics, our genomes, to our behavior is more than just like a philosophical argument. It has very real implications for how we structure our societies. And then, of course, they're with us always. Are you already in the eugenics class? Have you already had it? Or the genome class in which you had a session talking about eugenics? Yeah, okay. Right, so the history of genetics is eugenics. So this question has always been with us, and the pendulum swung from race is entirely genetic to race is entirely a social construct to something in the middle, but that requires a lot of nuance. Humans aren't always good with nuance. But it also has significant implications, like practical implications, not just because of eugenicists and Nazis who would use this and white supremacists who would use this information and do use this information for political ends, but also because of how we think about its relationship to healthcare and diagnosis, et cetera. There was some sense that it would be like using race as a proxy was sort of a step on the way to individualized care. For a whole variety of reasons, it's not an adequate proxy, right? And has anyone talked to you about the National Academy's report on the use of race and population in designing genetic research? Okay, I don't. I will circulate it. If I send it to you, can you send it to everybody? So now, a year and a half ago, the National Academies published a consensus study on the use of race, ethnicity, and other population identifiers in the design of genetic research. It doesn't solve all the problems, but two big points out of that. One, stop using the word Caucasian, that was a eugenicist word, just say white. Two, that in the vast majority of cases, you don't need race in the context of genetic research. What we actually need is social determinants of health data, which historically we have not had, but you need the social, because of the way in which, in particular in countries like the US, and the US in particular, the way that race is tied up with social determinants of health, you can't tease apart genetic data from social determinants of health data unless you have, you can't tell what the impact of the genetics is on the trait without also having the social determinants of health data. And we, as a community, have been sort of lazy about that and not rigorous, not only in the way we use race, ethnicity, population labels, but also in terms of analyzing genetic data when we don't have all of these other data that are necessary to put the genetic data in context. So please review that report. It has nice tables that say, here's the kind of data, and here's when it's okay to use it, and here's when it's okay to use race and genetics. It's almost never. The answer is it's almost never useful to use race as a label in genetic research. It is important for accountability from a government perspective, although who knows? My entire lecture comes with a caveat that I don't know what's going to happen next week. The ELSI program might disappear. NIH might disappear, I don't know. But historically, we have asked for accountability from researchers to ensure that they are recruiting diverse people into their studies so that we know that our federal dollars are benefiting our whole population and not just a subset of our population. And for those purposes, it is important to collect race and ethnicity data. Those labels should not then be imported into our research because it's almost never useful. This class goes till 12. Behavioral genetics, you mentioned, Cody, it's much more hand-wavy, right? Because they're all complex traits. And this was a huge part of eugenics, was behavioral traits, right? The eugenics lecture that I usually give, they have the kinds of things, the kinds of traits were, on the good side, elocution and golf playing. And on the bad side, ne'er-do-well and, pauperism, being poor, right? Those are the kinds of traits they associated with genetics. All behavioral traits. And again, if you view these as deterministic, massive implications for free will, moral and legal responsibility, treatment options, as I mentioned before, incarceration versus therapy versus drugs, etc. And things get really complicated really fast, right? This, again, I've been using this slide for a long time. It lands very differently now because we actually have access to just a ton more genetic data than we used to, right? But still, if you have a trait that has 5 genes involved, you have 243 possible genotypes. Just think about how much data you would need to tease out what was going on with a trait like that, right? So we just need to be very humble and mindful of how complicated it is. And that assumes purely genetic, no environment, etc. We've also been talking about human germline genetic modification for roughly ever. I think the first report on this topic was published in 1983. Like, long before we even sequenced the whole human genome, we were worried about genetically modifying the next generation. And the treatment enhancement distinction has also long been with us, right? The sort of key example here is human growth hormone, right? We give human growth hormone to kids who are going to be 2 standard deviations below the mean, because we live in a high-risk society and our built environments are built for people of average height. So we give human growth hormone. But what if a couple comes in and they both played college ball and they want their kid to have the best possible advantages in that regard? And so they ask for human growth hormone for their average or above average height kid. Like, how do we think about that?
I thought there was a study that disproved effects for normal statured individuals that didn't improve their height.
Oh, really? I didn't know that.
Sorry.
But that's the sort of case that we're talking about, right? Like, are we trying to get folks, is medical treatment designed to get folks up to a certain standard? Or is it okay if medical treatment is used to give new traits or to enhance traits above what would have been the case naturally? And how do we think about that? And what, in the case of human germline genetic modification, it's not just making those decisions for ourselves or the kids that are here, but for the next generation and for all generations beyond them. And how do we think about what is an appropriate use of such technologies? And going back to, Cody, your question about like what's right and what's wrong, right? This question was very much forced by this guy. Is everyone, I see some nodding. So this is Hujun Kui, who announced that he had actually done it. He had done CRISPR in embryos. It's not a particularly useful case because it's like if you could design a study that violated like every ethical principle, you'd get something close to what he did. But the question, this led to, like there were already international bodies who had put out statements about, since CRISPR developed, about what appropriate uses of genetic modification were. This case made everybody go back to the drawing board and do it again. And in terms of the weighing, right, the question is about the severity of disease, the probability of the disease, and not like this technology comes with risks. There are certain benefits that are worth it, and there are others that are not. So you would not, the recommendations are like, use this for like Tay-Sachs, use this for terribly debilitating, life-shortening disease. It is not, I mean, it's not safe enough to do right this second anyway, but the first things that we do should be those most terrible, 100% penetrant, fatal diseases, not things that would be, not like BRCA, where it's probabilistic, and if they do get the disease, it won't be until later in life, et cetera. So again, balancing, I'm all about balancing risks and benefits. I'm gonna skip through that. We talked a bit about direct consumer genetic testing. I've mentioned, I mean, this was a game changer in terms of privacy, as I've already discussed, just because so many people have access to their genetic information and have shared it in various ways, increasing risks to privacy for everybody, basically, just because all of that information is now available. Also made this possible. I'm guessing you know who this is. Do you know who this is?
I forget if it's like Golden Gate, but I know, was this the person in California?
Yeah, Golden State Killer. You were very, yes. So this was Joseph DeAngelos. He was the first person who was arrested for a crime based on investigational genetic genealogy. So this is using genetic testing, building a genealogical tree, finding the people in that tree who are in the right place, the right age, etc., getting samples, and then testing against a crime scene sample. Since his arrest, he was arrested, he was convicted, he committed many rapes and murders in California in the 80s. And since his arrest, over 100 other cases have been solved this way. His case in particular was solved by taking a crime scene sample, going to a website called GEDmatch, which was a third-party genealogy site where people could upload their 23andMe or Ancestry data and look for relatives, etc. It didn't have a firm policy on access by law enforcement. Law enforcement uploaded the sample, did exactly what I just described, identified him as a potential perpetrator, went to his house, took some of his trash, and got a positive match to the crime scene sample. After this came out, GEDmatch changed its terms of participation like 4 times, back and forth, like trying to decide how to do it. They then sold to Parabon, a forensics company, and Parabon was promptly hacked. So we are in a much different world now than we were in the late 80s at the start of the Human Genome Project. And again, as I said at the beginning, it's not that we haven't solved any problems, but the science keeps moving. Right? This is the Golden State Killer case is a very different place than we were 30 years ago, and changes how we have to think about these data, how they're used, stored, shared, etc. So before, I'm going to go into policy super quickly, but any questions, additional comments on the ethics side of things? All right, I only have 5 minutes. But the relevant policies, although I didn't add on the end, I actually have a couple slides on investigative genetic genealogy now, because there are 2 policies relevant to that kind of testing in the country, and one of them is here in Maryland. So the Genetic Information Non-Discrimination Act, which I've already talked a fair amount about. So I've said most of this already. It prohibits the use of the information in employment and health insurance contexts. So it was largely superseded by the Affordable Care Act, which also prevents discrimination in setting of premium amounts based on pre-existing conditions. But if the ACA went away, this would still be here from a genetics perspective. All of these types of information constitute genetic information for the purposes of GINA, and I'm happy to, I can send my slides to people. But again, as I said before, does not apply to life insurance, disability, long-term care, and federal employees in certain federal healthcare systems, although they are largely covered by comparable policies relevant to them specifically. You should all be familiar with HIPAA, right? This is the part of it's the Health Insurance Portability and Affordability Act that protects medical information
but important to note that once it leaves a covered entity like Hopkins and is not in a covered entity, its protections change. So thinking about what happens to data after it has left this environment is important. And genetic information does not count as identifiable for the purposes of HIPAA. The HIPAA identifiers are like traditional things you think of, like medical record number, social security number, name, birthday, etc. The Common Rule is the federal policy that governs human subjects research that's funded or conducted by the 17 or 18, depending on how you count, federal agencies and offices that are signed on to the regulation. It's common across all of them, hence the Common Rule. It's also called 46 CFR 47, which is where it is in the Code of Federal Regulations. Any research using directly or indirectly identifiable information is subject to review by an institutional review board. Genetic information does not count as identifiable for the purposes of the federal regulations. Research involving anonymized data is not subject to the Common Rule and does not require informed consent. I'm not going to go into this because of time, but there was, in 2011, the process started to revise the Common Rule because it had been around for a long time. Science had moved, it needed to be revised. One of the things they tried to change was this not human subjects distinction for genetic research. A couple of things happened. One, many members of the genetics community and our professional society said, no, you can't make us get informed consent for all genetic research. It would bring research to a halt. And the 2017 election did not go how Obama thought it would go. And so at the end of the Obama administration, they started just like trying to churn out as many policies as they could, as quickly as they could, and the final Common Rule was issued on January 19th as they were turning the lights out in the White House, and it did not include this change to the Common Rule. But they said, we sort of, in the text at the beginning of the document, we reserve the right to revisit this one piece without revising the whole Common Rule. Francis Collins and his right-hand person then wrote a piece about a year later saying, okay, it's time to revisit this. It hasn't changed, and I don't imagine anything's going to happen in the next 4 years on this. Within NIH, there are certificates of confidentiality. The 21st Century Cures Act actually made these much stronger. These certificates, you get them when you get an NIH grant, and they prohibit you from releasing research data to law enforcement. It used to give you the option to, like the ability to resist turning data over, but now you're prohibited from turning over research data to law enforcement. And I've already talked about Common Rule. The American College of Medical Genetics and Genomics issued in 2013 and have revised a number of times since, because we do know so much more about genetic data now than we used to, and we're doing so much more whole exome and whole genome sequencing. There was a push with a lot of help from the patient advocacy community to provide, if you're going to do whole exome, whole genome, to provide data back to folks that we actually know something about, right? So highly or pathogenic or likely pathogenic changes that would change medical management should go back to people if they want it when you're doing whole exome or whole genome sequence in the context of clinical care, regardless of what you went into the genome looking for in the first place. So these secondary findings should go back if people want them. I'm not going to go through the machinations that they went through, but I'll say that they're now up to pathogenic and likely pathogenic changes in 76 genes should go back to people when they undergo clinical whole genome or whole exome, if they want them. This was only in the recommendation is only in the clinical context, but lots of research studies are doing this as well. In part because on the argument that the risks of genetic research have gone up, and this is a way to provide offsetting benefits to folks who are participating in our studies. At the state level, most states have at least one genetic privacy law above and beyond anything in the criminal legal context. They all have policies in the criminal legal context. And there are 2 states, as I mentioned, that have policies about investigational genetic genealogy. One is Maryland, the other is Montana. Montana's has a loophole you could drive a truck through, but Maryland's is actually quite good. I played a very small role in it, but it was really driven by the work of Natalie Ram, who is a lawyer and scholar at the University of Maryland and also has an affiliation with the Berman Institute of Bioethics. So the law in Maryland has structures in place for law enforcement to request and get access and protections not only for the folks whose DNA they find who is ultimately identified as a suspect, but also for related people whose data gets extracted into the investigation. It was a very, I think, robust and inclusive process in terms of bringing in all the stakeholders into the process of building this legislation to ensure that the interests of both the police and potential suspects were included. That's the entire Montana code. And the problem here is that it says, unless the consumer whose information is sought previously waived the right to privacy information, and they don't define what that would mean. So simply uploading your data into what you thought was a private database could constitute waiving your right to privacy in that information. And that's it, and there's a bunch of evolving issues, and thank you very much, I'm sorry again about starting late and losing it in front of you.
Thank you for joining us.
This is the one I know. Brain break.
Yeah, if you're free, it's kind of a few minutes if you need about 10 minutes. I want the background.
I'm not ruining it that day. More than it already is going to be tested.